Dividing polynomials through long division. Let's get a refresher on long division with numbers. Let's say I ask, what is 1024 divided by 7? When we format our long division, the first number represents what we call our dividend, and that's what we put underneath the division bar. What we are dividing by is referred to as the divisor. Carrying out the long division, how many times does 7 go into 1? 0. 0 times 7 is 0. Subtract that value, we get 1, bring down the next term. How many times does 7 go into 10? We get 1. 1 times 7 is 7. Subtract, bring down the next term. How many times does 7 go into 32? 4. 4 times 7 is 28. Subtract, 4, bring down the next term. How many times does 7 go into 44? 6. 42 through multiplication, subtract 2. There's nothing else to bring down. We're done. So the quotient, which is referred to as our answer here, or the result, if I could spell it right, that would help, of this division process. This 2 is our remainder. So formatting our answer, 146 and 2/7 is the result. So the quotient plus the remainder over the divisor, this is equal to 1024. So if we were dividing 1024 by 7, we get this plus this left over. Now, that process that we did with numbers is the same as what we would do with polynomials. So let's just jump right into an example. Let's say I had 9b cubed minus 85b squared minus 95b minus 25. We were dividing that by the polynomial 9b plus 5. So what you're dividing by is your divisor. Now what you want to look out for is, are the polynomials in standard form, meaning the exponents descend in order, and does it skip over any degree terms? So when I look at this polynomial that represents my dividend, the terms in by degree go 3, 2, 1, 0. So it's not skipping anything. In the event something was skipped, we would want a placeholder. Much like when we divided by, or we were taking 1024, just because there's not a number here in the hundredths place doesn't mean we just eliminate it and do this instead. So we have that placeholder for the hundredths place. So in the event a degree is missing in our polynomial string, we want something in that place so that everything lines up. And we'll see in another example why that's important. But we don't need any placeholder here, so we're just going to put that polynomial in its spot for the dividend. Okay, so carrying out the division is the same as it was with numbers, except there's more than one term in our divisor. So what do we look at? We're going to look at the first term in our divisor and the first term in our dividend to start. Okay, so we looked at the first term in our dividend with the numbers, first term in the dividend to start. How many times does 9b go into 9b cubed? Or another way to ask that is, what is the result of dividing that first term on the inside by the first term on the outside? That'll tell you how many times 9b goes into that first term. The answer to that is 1b squared. With the numbers, once we had a value in our quotient, we multiplied that by the divisor. So we're going to need a distribution here, and we will get 9b squared plus cubed plus 5b squared. At this point, we subtracted this new line we put in our division, but we have more than one term. So we want to be able to subtract this whole thing, which means the signs are going to change. Distribute that -2 through, I should say. So it's going to minus minus. Now these first terms cancel. Combine like terms here. We're going to get -90 b squared, bring down the next term. Once we've brought down the next term, It's just a matter of repeating that process over and over and over again. So if you can get to this point, there's no reason why you can't finish the division problem. The only difference is now we have our new term that we're trying to determine what this first term in the divisor goes into. So that will get us our next term in the quotient. If we take 9b and ask ourselves how many times does it go into negative 90b squared? Or another way to look at that is what is negative 90b squared over 9b? And that's going to be negative 10b. Once we have a value in the quotient, multiply it by the divisor to get our new line in the actual long division. We'll get negative 90b squared minus 50b. At this point, in our numerical example, we would subtract this value. There's multiple terms here, so we want to subtract this whole thing. So that negative distributes and changes all the signs. It becomes plus plus, cancel. We get negative 45b, bring down the next term. Again, once you've brought down a term, repeat the process. You have your new leading term that you're going to use to get the next value in the quotient. So how many times does 9b go into negative 45b? Or what is negative 45b over 9b? You're going to see that that is negative 5. Once we have that term in the quotient, we're going to multiply that by the divisor to get our next line. And that will get us negative 45b minus 25. We're subtracting this whole value. So the negative distributes, the signs change to plus plus, cancels, 0. There's nothing left to bring down, so we are done. 0 is our remainder. What we have up here is our quotient. So this is the result of dividing those two polynomials. In our next example, we have this cubic binomial divided by a linear binomial. We know what we're dividing by is our divisor. However, you'll see in the dividend, we mentioned in the previous problem, we want to look for placeholders. We have a cubic term, but we're missing a quadratic and a linear term. So the placeholders, what they look like is you're just going to do a plus 0, and then the variable raised to whatever degree is necessary for that missing piece. So plus 0n. So in this case, we needed 2 placeholders. We could have 1, we could have 2, we could have more than 2. Okay, but just be on the lookout for the need for placeholders, and you'll see why when we carry this out. Everything will line up nicely when we remember to do those placeholders. So first term on the inside divided by first term on the outside will tell us how many times n goes into n cubed, which is n squared. Multiply by the divisor, we get n cubed minus n squared. We're subtracting this whole thing, so a negative distributes through. We get minus plus, the signs change, these cancel. 0 plus 1 is 1 n squared, bring down the next term. So you can see if I didn't have that plus 0 n squared, that n squared that we put here would be lining up with the negative 4. And you'd be asking yourself, well, these aren't like terms. I can't combine these vertically. So you may be confused on what's going on. So that's why the placeholders are nice in the sense that it helps everything line up. Now, we have our new initial term. How many times does n go into n squared? Or what is n squared divided by n? And we'll get n. Multiply by the divisor to get our new line, n squared minus n. Subtract that new line, so run a negative through. First terms cancel. 0 plus 1 is 1, n. Bring down the next term. New first term, how many times does n go into n? 1 time. Multiply, n minus 1. Subtract that line, get negative 3. That's our remainder. Quotient. How do we format our solution when we have a remainder? We're just going to do quotient plus remainder over divisor. Now, doing a plus a negative 3 up top, we don't need. We could have just done minus, but in general, we just do plus. So in general, it's quotient plus remainder over divisor. So you're going to format your final answer when you carry out the division between the polynomials. And then one last example, because the 2 examples we've seen so far is when we divide by a linear binomial. Let's see when we divide by something of higher degree, say a quadratic. Okay, in the final example, we have a quartic divided by a quadratic. So let's set this up. When we set it up, you actually want to look for placeholders in both the divisor and the dividend. So there's nothing needed for our divisor, and we haven't seen that in the previous example. It just went from the linear term to the constant term, so there's nothing needed there. And for this dividend, we're not missing any terms either, right? The degree of each term goes 4, 3, 2, 1, 0. So I don't need anything to hold its place. Now, carrying out the division is identical to the linear binomial cases, except with the linear binomials, we were dealing with two terms all the way through because we were dividing by two terms. Now we're dividing by a trinomial, so we're going to be working with three terms all the way through, and you'll see that as a result of the multiplication process. But how we handle it is no different. Start with the first term on the inside, first term on the outside. So how many times does 2x squared go into 4x to the fourth? Or what is the quotient of 4x to the fourth over 2x squared? We're going to get 2x squared. Once we have that term, we're going to multiply it by our divisor. We're going to get 4x to the fourth plus 2x to the third minus 24x squared. We want to subtract this whole line, so a negative has to run through and all these signs change. So we're going to get negative, negative, positive. Now at this point, these terms cancel. We're going to get negative 16x cubed plus 10x squared. And we bring down the next term. So we want to bring down that next term because we're dividing by three terms. We want to be working with three terms the whole way through. So if I didn't bring down that 110x, I'd only be working with two terms. Now I have a new leading term, so that'll get me my next term in the quotient. So negative 16x cubed divided by 2x squared is going to be negative 8x. Multiplied by the divisor, we're going to get negative 16x cubed minus 8x squared plus 96x. We're subtracting this line, so the signs change. It's going to become plus, plus, and then a minus. First terms cancel. We're going to get 18x squared. And then we're going to have plus 14x minus 84. So we're working with three terms. Let's get our next term in the quotient. It's going to be 9. Multiply 18x squared plus 9x minus 108. Subtract that line, so change the signs. Minus, minus, plus. Cancel. We're going to get, it looks like 5x and then 24. Okay, there's nothing left to bring down. So this linear binomial expression represents the remainder. So sticking with the format that's needed to write my answer, we're going to do quotient plus remainder over divisor. So here's an example where we divided by a quadratic trinomial. We worked with trinomials all the way through. Our remainder is an expression itself with a variable term. And there's our final answer. So the process is the same. We're not going to get just a single number for remainder in this case, but no worries. We handle it the same way. So there is the solution to that problem. And that will conclude the video on long division with polynomials.